Hi friends, welcome back. Let's continue with the intermediate code in the compiler design. So in the previous video, I explained what exactly the intermediate code was. Now let's see the different forms of intermediate code. The intermediate code can be represented in three forms. One is the abstract syntax tree, polish notation, and three address code. Okay. So now first let's see what is this abstract syntax tree. So this abstract syntax tree are more compact than a parse tree. The first thing is abstract syntax tree are more compact than a parse tree. So you know the parse tree, just taking the values and representing in the form of, taking the expression and representing in the form of a tree. So this abstract syntax tree is more compact than a parse tree and can be easily used by the compiler. And can be easily used by compiler. Okay. So let's take a simple example for this abstract tree. The example, let me take A star B plus C. So this is an expression. Okay, so I'm going to represent this expression as star is having the highest precedence. So just take star A, and here in the B plus C, the plus is the operator here and the operands for this is. So this is a representation of tree. That is a parse tree. So this abstract syntax tree can be represented like, so this is a parse tree, you know that. So I want to make abstract tree because abstract trees are more compact than the parse tree and it can be easily used by the compiler. How the compilers are easily using this abstract syntax tree rather than parse tree? Because this abstract syntax tree is represented as it's just like a memory locations, just taking star and the stack. So this is A and this is represented with the plus and these are the operands. So this is an abstract syntax tree for that expression. So it can be easily understood by the compiler rather than the parse tree. Okay. Now let's see the second one. What is the second one? There is a polish notation. The polish notation are of three types. One is infix, prefix, postfix. Infix, prefix and postfix. Okay, so infix means you already know, it's just an operator in between the operands, you call it as infix. A plus B, let us take. Prefix, pre means before plus AB. Post, after the operator. You have to target only on the operators. Okay, if the operator present in between the operands, then it is in. Pre means before, the operator has to be placed before. Post means after. AB plus. So this is how you are going to represent this polish notation, infix, prefix and postfix. Okay. So let's take one of the postfix expression. Let me explain the postfix notation. Postfix notation. Okay. So the postfix notation, it is useful form of intermediate code. The first thing is it is a useful form of intermediate code if the given language is an expression. If you have to remember that the given language is, if it is represented in the form of expression, then it is useful for intermediate code. It is also called as suffix notation or reverse polish notation. Reverse polish notation. Okay, the postfix can also be called as suffix notation or reverse polish notation. So the postfix notations is a linear representation of syntax tree. So in this, let me write those points. we are discussing the postfix. In the Polish notation, we are discussing about the postfix notation. The postfix notation is a linear representation of syntax tree. In this notation, any expression can be written unambiguously, so without the parenthesis. So let's see the example again. Okay, so in the I said, if you take x plus y, it can be represented as xy plus. So that is a postfix. We are just placing the operator post. So let's take in the terms of productions. Let's take the example for the postfix notation. The productions for this is, the productions are E determines E1 operator E2. Operator may be anything, plus, minus, divide, whatever it may be. So E determines E1 and E determines ID. So this is the production. So then what is the semantic rule for this production? Semantic rules. So we are talking in terms of SDT. The Polish postfix notation in terms of SDT. Okay. So postfix notation. E dot code is equal to, so you have to place the operator before the operands. So E1 dot code value, whatever you want, you can take. E1 dot code slash E2 dot code slash operator. Okay, and this E dot code is equal to E1 dot code, and finally E dot code is equal to ID. So this is a way you are going to represent the postfix notation in terms of SDT, the productions and the actions for that productions. Okay, so let me take simple example for this postfix notation again. Just I want to show you how the operands and operators are C minus D plus E plus F by G. So this postfix we already learned in the data structures, everything. So we know the precedence or brackets is having the higher precedence, next into and divide is having the next precedence, plus and minus is having the next precedence. So like this the precedence is decreasing. So first concentrate on the parenthesis. Okay, so just concentrated on parenthesis. Z is equal to AB minus, so just remove the parenthesis and make it as a postfix, star CD minus plus E plus F by G. So just look about now focus on this parenthesis, AB minus star CD minus plus. So just remove this parenthesis, E, this is having the higher precedence, so E F G slash plus. So next concentrate on here. The final Z is equal to AB minus CD star, next CD minus star E F G slash plus plus. So this is the postfix notation. Postfix notation for the given grammar. Thank you.